Welcome. This is the Cisco CCNA ENSA, also known as the Enterprise Networking Security and Automation course. This course focuses on the CCNA version 7 curriculum. This is course 3 of 3. Module 6, Network Address Translation for IPv4. So, Network Address Translation, commonly referred to as NAT. In this video, we're looking at NAT characteristics, types of NAT, advantages, disadvantages, and then static, dynamic, PAT, and we're going to end with NAT for IPv6. So, essentially, what are some of the main characteristics of NATs? So, private addresses came into effect a while ago. Those are going to be non-routable addresses. They're not allowed on the internet. For Class A network, it's 10.0.0.0 through 10.255.255.255, or it's a 10 with a /8 with slash notation. For Class B, it's going to be a 172.16 through 172.31 and everything in between. The network range is going to be 172.16.00/12. Lastly is a Class C network, which is 192.168.0.0, and pretty much anything in that range. So if it starts with 192.168, that's a Class C private address. And again, the network range is going to be 192.168.0.0/16. So why does that matter? Well, when we're talking about NAT, the purpose of NAT is essentially to take all of our private address spaces and allow them the ability to get on the internet. And we do that through the network address translation, because the purpose of NAT is to provide the translation between private addresses to a public address. And so what I mean by that is, here we have an internal private address. Let's say this is your house, this is your business, whatever, it doesn't really matter. In order for your addresses to get on the internet, they have to go through a NAT router. So the NAT router will actually translate any internal address to an internet capable address. If you're at your home, you may only have one IP address, and they use different mechanisms to make sure that each of the home devices can get on the internet. If you're in a business setting, you may have multiple public addresses, and each of those public addresses are allowed inside access to certain resources. It really just depends on how they're configured. So, again, NAT allows us to take a private address space and convert it to a publicly accessible resource. It allows it to gain access to the internet. Normally, NAT is done on a stub network. Stub network is just a clever way of saying it's a network that contains itself, and it's kind of more like an end-based network. There are no networks that connect through this private address space. And again, the important part here is it's going to mask all of the internal private IP addresses, so they are allowed on the internet. So how does NAT work? So let's assume PC1 wants to communicate with the server. Well, the issue is PC1 has a private address, so it won't be allowed on the internet. So PC1 will send a packet address to the web server to the default gateway. Default gateway will forward it appropriately. We're going to assume that this guy right here, R2, is the NAT router. So this is actually our internet device. So R2 will receive the packet and read the source IPv4 address to determine if it needs translation or not. This is going to be something that's internet capable, so it knows that private IPs aren't allowed on the internet. So if it knows the private address spaces, it will determine that it is not allowed. Thus, it will need to be translated to a private address. So R2 will add mapping to the local, from the local address to the global address to the NAT table. So what we'll have is we have our local internal. That's going to be the source IPv4 address. That's going to be changed to our inside global address. That's going to be the temporary address that we're going to be using to be able to send that data. R2 will send the packet with the translated source address towards the destination. The destination, you'll notice, destination is still going to be the same. And the destination still is going to be the same. So the outside local and outside global is essentially just saying the destination. So R2 will send the packet with the translated source towards the destination. The web server will respond with a packet address to the inside global address, because basically as the packet flows out of R2, the IPv4 source address is now changed to the inside global public address. So that means for all intents and purposes, all returning packets will have the inside global address, or the public IPv4 address. So the web server will respond with the inside global address. R2 receives the packet with the destination address. R2 will check the appropriate NAT table, and then we'll do the correction, and we'll change it from the inside global to the inside local, and then forward it appropriately. This is something that your home router does automatically, that without any setup. At home, you may end up with a network that has like 192.168 or a 10 network. Well, when you go on the internet, what ends up happening is all of your addresses will have to be translated to your inside global address. That is why if you go and you Google what is my IP address from any device on your internal network, they're all going to have the same IP address. It's not that each device has that same address. It's just you are actually looking at your global address that's the router showing from the internet's perspective. So, terminology. You need to understand inside local, inside global, outside local, outside global. Inside address, that's going to be the device being translated. The outside address is going to be the address of the destination. The local address is the local address and any address that appears on the inside portion of the network. And then our global address is going to be the global address and the address that appears on the outside portion of the network. We have our inside local. In this example, we have our internal address, the 192.168.10.10. Our inside global address, this will be the source address after it leaves the router. So here is our router. That's going to be happening. So our inside local, source address, destination address, source address, destination address, and then this is going to be as it comes back. So our source address is going to be going to our web server. After NAT, our source address will be changed from the inside local to the inside global and keeping it to the same destination. The destination address doesn't change. Even though it may say outside local and outside global, you're going to notice the destination address in this example are the exact same. That's going to be sending it to the web server. The web server will respond. The web server now becomes the source address. That's still the outside global address. As it comes in, it will be sent to the inside global address. The router will receive the packet using the appropriate inside global address. The router will look at its NAT table and will translate that back to the appropriate inside local address. Still keeping the outside local address as the source, but the destination is changing from the inside global to the inside local, showing the appropriate internal network. That way, there is a specific flow of that traffic that the router has to map. If the router happens to be restarted, all of these connections are terminated. So the NAT table is stored in memory, and when the device is restarted, all the information of that is lost. And that is it for this module. If you got any questions or concerns, please reach out. Thank you.